So this is Roman numeral 2 in your notes as you were writing these down. Scientific method. The definition of the scientific method is an orderly, systematic approach to solving problems. Another way of wording it is it's a way of answering questions about the world in which we live. So here you have I brought a picture in of a chemist in a laboratory that is looking at a sample here in a petri dish. But they are trying to, obviously, they're working on figuring out some sort of problem or identifying um, what they're looking at here. So using the scientific method is an orderly approach to solving problems. Now, the steps of the scientific method, first of all, you have to make an observation. So the first key word is to observe something of scientific interest. Observe, step one. It's very important for a scientist to be very tuned in to any observations, quantitative and qualitative. Identify the question and or the problem. So identify what it is that you're trying to solve, what it is that you're puzzled about. 3, form a hypothesis. Now, the traditional definition of a hypothesis is that it's an educated guess. A hypothesis is a temporary explanation for what you observed, but it's an educated guess based on your best knowledge, your education, your depending on your level of knowledge you may have. It's your best guess as to why what you observed is occurring. Now, the thing about hypothesis that you want to be careful about or that you want to understand is it is tentative, okay? Which means it's not necessarily true, but using your knowledge that that's your best guess. It's an educated guess. Another thing that's important to remember about the hypothesis is it must be testable. You've got to be able to test your hypothesis. And then it's usually written in a cause and effect statement. I just mentioned that your hypothesis must be testable. So the next step is the experiment, or you would test your hypothesis. During the experiment, you're going to record any observations that you make and collect your data. You always want to pay attention to both qualitative and quantitative aspects. Be as thorough as possible. So for example, if you have a color change, that will be the qualitative, like if the color changed from red to blue, or if the color went from pink to clear, colorless, you would want to record that. That's qualitative information, descriptions that are non-numerical. But then you also want to be quantitative in your recordings because oftentimes we have to graph our data. So you would want to include quantities. Next, during the experiment, you would analyze it. Once you've collected the data, you're going to analyze your data. And usually the way that a scientist would do that is with a graph. Next, you can start drawing some conclusions. So once you've completed your experiment and you've analyzed your data, you begin to draw some conclusions. If your hypothesis was incorrect, you want to reformulate your hypothesis and then repeat steps 2 through 5 as you retest. One thing about the scientific method that's important to understand is it is very important you understand it is a cyclic process. It's not, steps 1 through 5 and you're done. So it's a continuous thing. And normally, you hear that you want to do at least 3 trials. You want to be able to get a good data set to look for a trend and to not to understand that it's like just because it happened one time doesn't mean it's repeatable. It's got to be repeatable. So, it is a cyclic process. There's really nothing to copy from this slide, but it's just the picture of the fact that it is a cyclic process. It moves from one to the other step, and then it may even cycle back around. Um, and you retest and you look for trends. Now, another two terms that I want to kind of differentiate between two terms that are commonly used interchangeably, but they're very different, um, is the difference between a theory and a law. The definition of a theory is a theory explains why nature behaves a certain way. Theories are well tested, but they're not proven beyond the shadow of a doubt. In other words, there's a chance that somewhere in the future, as more knowledge is gained, as more testing is done, and as technology is improved, that maybe in the future, um, scientists may be able to answer even better, and they may have to reformulate that theory. So there's always a chance with a theory that another experiment could cause you to need to be able to change it or to tweak it. To Theories evolve over time. That's important to understand. They're not 100% set in stone. There's a chance a theory could change or could be altered at some point. But a scientific law or a natural law is defined as something that describes how nature behaves. If something is a law, it is a fact, and facts do not change. So laws will not change. They cannot be disproven. They tell you what happens, but not why it happens. So theories explain why, and theories can change as new and better knowledge is gained by scientists. But a natural law, like the law of gravity, it's not going to ever change. We're going to learn about gas laws in this unit. They're mathematical calculations that we do, mathematical formulas. They always are going to be set in stone. Theories change, laws do not. Laws tell facts. So just kind of a comprehension check here. I'm going to show you a statement, and I want you to determine if you think it's a theory or if you think it's a law based on what we just went over. Here's the statement. Matter is neither created nor destroyed in a chemical change. Matter is neither created nor destroyed in a chemical change. Take a moment to think about that in your mind and think about how you would answer. Is that a theory or is it a law? I'll give you a little moment. All right. Hopefully, you said that this is a law. This is called the law of conservation of mass or the law of conservation of matter. It says matter is not going to be created, nor is it going to be destroyed during a chemical reaction. It just states the fact. Matter cannot be created, nor can it be destroyed in a chemical reaction. All the matter that's present in the beginning has got to be accounted for in the end during a chemical change. So this, hopefully you said, was a law. It explains what happens, not why it happens.